In this video, we're using our same ellipse that we had earlier, only in this case, we're going to find the minor axis. And the way we can do that is we're going to draw in here the major axis. So there's the major axis. And to find the minor axis, what we need to do is bisect this segment that joins the two foci. So we're going to do that by setting up this compass. We're going to put the point of the compass at one foci and then adjust the other side of the compass so that it is more than halfway between the two foci. And then we're going to make an arc on each side of the major axis. Then we're going to move the point of the compass to the other foci and repeat that by drawing an arc on either side. Then we're going to draw a line segment through those points of intersection. And there we have the minor axis of the ellipse. Now, in previous videos, we said that the distance from the center to the focus, in other words, this distance here, is c. And then the distance from the center to this endpoint of the major axis we'll call a. So that distance from the center to the endpoint of the major axis is called the semi-major axis. And we also said that the eccentricity e of the ellipse is equal to the distance c divided by the distance a. Okay, well here's another interesting point. We have another measurement, which is going to be this one, which is the distance from the center to the endpoint of the minor axis. Now that distance is actually half of the minor axis, so we'll call it the semi-minor axis. And this makes a triangle. We can actually turn this into a triangle. And we'll complete that triangle by drawing in the hypotenuse of the triangle, which goes from the focus to the end of the minor axis. Okay, now here's a question. What is the length? What is the length of that hypotenuse? Well, that's interesting. What we're going to do is we're going to use another piece of paper here and make a couple of marks on the piece of paper. One here at the center of the ellipse and the other one at the end of the major axis. Okay, so you can see those 2 points pretty clearly. All right, there's one point right here, and the other point is right here. So if I move this piece of paper like this, I can see that the length of that hypotenuse is the same as the length of the semi-major axis. So that means that this distance here is a. Now, putting all of that together, since that's a right triangle, and I know that's a right triangle because I know that the major axis and the minor axis are perpendicular to each other, we can then say that b squared plus c squared is equal to a squared. In other words, the Pythagorean theorem. We can subtract b squared from both sides of the equation and get c squared equals a squared minus b squared, and then take the square root, and we get c is equal to the square root of a squared minus b squared. Now what that does for us is it allows us to calculate this focal distance from the center to the focus. It allows us to calculate that if we know what the major axis is and if we know what the minor axis is. We can square the length of the major axis, or rather the semi-major axis, subtract the square of the length of the semi-minor axis, and take the square root of the result, and that will give us the distance from the center to the focus. So we'll come back in the next videos and apply this.